Okay, let's take a look at Lab3 here. We're going to right click on it and we're going to say export program, and under export program we're going to export it to microvision, which is really KEIL. We're going to save file. We're going to go up here, we're going to right mouse click, we're going to say open containing folder, and we're going to right mouse click and we're going to say extract all, and under extract all we're going to browse as we've done before to downloads, to embed KEIL, and select folder and say extract. Once it's extracted, we're going to double click here. We're going to double click here on Lab3, and it's going to launch KEIL. It's going to bring it up like this. We're going to go here, we're going to go to Lab3, there it is. We're going to go to the third from the left icon here, which is going to compile with 0 errors. Then we're going to go to our flash. We're going to say configure flash tools. We're going to go to device. We're going to bring up the right device, which is again at the bottom here. And it's a third from the bottom. We're going to go over here to debug. We're going to select Simsys DAP. We're going to go to settings and we're going to change it from any to DAP link, and then we're going to say OK, OK, and then finally debug, start debug session. Now if we notice our screen, we have some text on it, and if we look at what the program does, it's going to clear, position, do a bunch of stuff here. So what we're going to do is we're going to set a breakpoint here, and we're going to reset. We're going to run to the breakpoint, and right now we're at the clear function. So look here, this is step into or step 1 line. Let's see what that does. So if we hit this, we go into the clear function itself. So it doesn't just execute it and go on, it actually drops you into the clear function so we can see what's going on. Now if we step over the printf here and execute it, you'll see that the screen hasn't cleared. So when the printf is executed, it does not do this printf immediately, and when we do another step over here for fflush, when the fflush is complete, the screen is clear. So the concept is when you print something, you have to fflush it to standard out, which is your screen, to make sure that that printf is gone to the screen. Otherwise it sits in a buffer and the screen is not updated. Let's reset again, and let's run to our breakpoint. And this time what we're going to do is we're going to do a step over. Now if we do a step over, it actually does everything that's in the clear function here to clear our screen, as we can see here, and then it's going to continue on with position. Let's do a step into or step 1 line here, and we can see that it's put us into the position function. And if we do a step over here a couple of times and we take a look, it has not positioned the cursor where it should. The cursor is still up here. But if we do another step over here and it executes the fflush standard out, then it actually does position the cursor at the top of the screen as it's supposed to here. Now if we go continue a step over, it puts us back into our main line where it says print your name. Now when it says input your name, it's not going to execute that right away. Let's take a look at that again. So if we do a step over, and at this point it should have printed your name, it hasn't printed your name. So it doesn't do print your name because it's already executed this instruction, but this text is sitting in a buffer. So this is a very important thing, that when you do a printf, if you want the output to go to the screen right away, you have to fix it by putting in fflush standard out. When we look at Lab3 Question 7, it says after watching this video, when a printf is executed, does the output of the printf immediately go to the screen? And the answer here is no. And the way we fix this is putting fflush standard out, where standard out is our screen, to make sure it flushes what's in the buffer from the printf to the screen, to make sure that happens before you go on to any other code that you're going to do. Now when you're troubleshooting code, step into, which is step 1 line for the ARM KEIL debugger, step into actually when you are on a function takes you into the function, whereas step over actually executes everything in the function and then continues on to the next instruction in your program. Now if we take a look here, you can slide this up and make it a little bit bigger, and what we'll find is we have name in here. If we click on it, You'll see the light flashing on your Freedom 22F. It's using the Simsys DAP and the serial port to actually send this information, the debug information, back and forth. So it's going to take a little while to update because it's using your serial port in the Simsys DAP to actually send stuff to your PC screen, but at the same time it's going to be using that to send debug information, as we can see here. Now if you take a look, this is our name array. So what we have in here is random characters in here. It's not going to have all zeros or anything specific. It's going to have a bunch of stuff in it that's random because of all the memory that you have, whether you got ROM, RAM, whatever, this is in RAM memory, and RAM is changeable. And the thing is, when you power up RAM, it's full of random stuff. And that's what we have in any array or any variable. When you start programming, it's going to have a random value until you actually update it. So I'm going to set a breakpoint down here at this line here, and I'm going to run down to that line. And right now it's got input your name. I'm going to say Dave Ross, hit enter. And right now we can see that we're down at this line here. Let's take a look at our array. And we can see in our array we have DAVE space ROSS and a 0D, because the 0D is the carriage return or enter key that we've hit here. So our carriage return goes in as a 0D. So when we execute the next line here by saying step over, it's going to change that 0D to a 00. Because as you know, when you're going to do a printf or anything else, the string that you're printing has to terminate with a 0. So when you print all of this stuff here, it has to be terminated with 0 to use the next line, which is your printf %s. So I'm just going to run to the bottom here, and let's take a look at our screen. And you can see that on our screen we've got our full name printed here with hit any key to continue. So when we declared any unsigned char array, all the elements are random. So there is no default value because arrays are put into random access memory, which has random values when you first power it up. So there is no default value. Any arrays or any variables are always put into RAM. Character is put into the array when you hit the enter key. PCs is an enter key. On Macs it's a return. Value 0x0d, which is our carriage return. And what do you have in string arrays when terminated character is 0x00 hex, or you can put in quote \0 quote.